Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama-BUENA Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Marylou.
You sure about that?
Yeah.
Okay.
Maybe not today. You need help with your math homework today? We have tutors here till 5:30. You can call us at 636-4357. If you're calling from San Luis Obispo, you could call toll free at 1-866-636-6284. You can email us at dothemath@kern.org. Or you can watch us online at YouTube, Facebook, Twitter, Instagram, all that wonderful things.
There you go. Well, as Marylou said, we do have phone tutors available until 5:30. It is Halloween today, and lovely effort with the hair. I tried to do a little bit with my own, but I just couldn't do the same thing. Anyway, so I need you to step out in front a little bit so that we can get some photos of the entire costume here. So that way they can, I don't know if, were they able to see, because you've got some, it's a colorful costume.
It's a colorful, because I am a rainbow troll today.
All right, so, okay, so, because you needed to put some explanation to that, because I know there are some kids probably going, she's dressed up, but what is she?
Yes, I am a rainbow troll because our theme at school was trolls.
Okay.
So I kind of decided to be a rainbow troll.
Well, there you go. Nicely done.
Thank you.
And we're glad you kept that on for the show this afternoon.
Thank you.
All right, well, you know what? We do have a lot of things going on this afternoon. We have a very special guest in studio. We will be going out live to the tower on the, out at the airport, out at Meadows Field. So we're going to find out what goes on in the tower, because we've done a lot of shows with aviation, planes and things like that, and classes to become a pilot. But the people that control all the planes, that's what we're going to find out what they do today. But before we get to all of that, let's take a look at today's Math in the News. All right, now I know that you requested to be on air on Halloween.
Yes.
All right, and I made sure that we had Marylou on air during Halloween, and a lovely outfit once again.
Thank you.
And I figured, all right, since it's Halloween, we might as well tie something in as far as mathematics goes. So we've got a variety of masks here, all right, and we can see these are some of the ones, superheroes and some pretty ones that a lot of kids would be familiar with.
I saw some really scary masks today.
Right,
though.
well, we didn't want to put too many scary masks up
Thank
here.
you.
So these ones are not as scary as some of the other ones that are out there. And this one for one of our producers, Mackenzie, big ape fan. So we put that one out there. So that's how we're going to tie this into Halloween. Now you'll see how we tie this into math in just a moment.
Okay.
All right. Now the Bengal tiger that you see right there is the national animal of both India and Bangladesh. Now, if you come across one of these tigers, you may want to get out of the way.
Yeah, any
All right,
tiger, I think I'd get out of the way.
Right, as beautiful as they are. You don't want to come across. For the millions of Bengals and Indians who live in those countries or who work around there, it's easily, you know, like, oh yeah, I can easily get out of the way if I need to. It's not that easy,
okay.
All right? So what they did is, because a lot of them were being attacked, okay? Because if a tiger is hungry enough, it will eat what it can, okay, and will attack. So what they wanted to do was come up with a solution so that the people that were working in the area wouldn't be attacked as often, all right? And I kid you not, this is what they came up with. All right. These are women gathering honey. And what they are is they're wearing masks on the backs of their head. Okay.
Okay.
Okay, so you've got it. So they're walking forward. They're walking away from us right now, but they have a mask on the back of their head, so it looks as if they're looking at us.
Okay.
Okay. So, and what they said is, for the past 3 years, no one wearing a mask had been killed. Okay.
I'm still trying to put this together.
So, tigers have been seen following people wearing a mask, but they haven't attacked them because they have this perception. They're thinking that the people are looking at them.
Instead
So
of
therefore,
running
they
from them.
instead of coming up behind them.
Okay.
You see what I'm saying?
Yes.
So they would stalk them and come up behind them, right? So 29 people that were not wearing masks were killed in the last 18 months.
Wow.
And those wearing masks were not killed.
That's amazing.
That's what I thought
That's
too.
amazing. Something
right?
as
So I
simple
saw
as
this
that?
story. Now, it worked, but it hasn't worked forever. So it worked for a little while, but I think they're like, all right, the tiger
got
attacks are
smart.
getting, right, they're catching on.
Yeah.
And anyway, so I saw that story, and I thought it was pretty interesting how that kind of worked for a while,
Yeah.
you know, at least for a couple of years. But then I was like, all right, so the masks, so we can tie this into Halloween with masks on Halloween and things like that. But then it's like, how are we going to tie this into math? So masks, you know that a lot of kids and adults in particular will wear a mask of a presidential candidate, okay? So we can see right here that Spirits, this is a big Halloween firm, all right? Spirits Index has accurately predicted the outcome of every presidential election since 1996 based on their top-selling candidate mask. So since 1996, the candidate that sold the most masks was elected, okay? Now, let's take a look at some definitions here. So random sampling is a part of the sampling technique in which each sample has an equal probability of being chosen. A sample chosen randomly is meant to be an unbiased representation of the total population. So let's take a look at a problem. Random sampling, all
Yes.
right? So if you were doing a survey or something like that. If each member of a population has an equal chance of inclusion into a sample, it's called a random sample. It's unbiased. So they can say if you wanted to know how many red marbles were in here, you would take a sample of this whole thing, get a smaller size of it, count them, and then that's how you would figure out the ratio from red to blue or something like that. And that is today's Math in the News, how we can tie the masks into somebody that was actually using a mask to help save their lives while they were working. And I just think that that was a very clever idea
That is.
on how to go to work without being attacked.
Yeah.
I mean, so, have you ever heard of something like that before
No.
today?
No.
I didn't hear about it either until I read about it. But anyway, we have Nandana in studio. Why don't you let everybody know where you go to school and what grade you're in?
I'm in 5th grade and I go to Stockdale.
And how is Stockdale?
Stockdale's a pretty good school and I have a lot of friends there.
Well, good. Have you been there for a while?
Yes, but I left for 3rd grade.
So you left for 3rd grade and then came back. All right. Now, so you have a lot of friends. What's the best thing about 5th grade? Because you've been in it for a couple of months now. So is there anything really cool about 5th grade?
I don't know. Well, maybe getting to be older. I don't know.
Well, you know what, getting to be older, getting to do a few more things and stuff like that, right? So I know that once you get into 5th grade, you guys can start like chorus and band and sports and different things like that.
Yeah, it's really fun playing the violin because it's my favorite instrument and now I really get to play it with my classmates.
Well, good. And you've been doing that for a while?
Mhm.
How long?
I don't really know.
More than a year?
Yeah.
Yeah? Well, so you must be pretty good at it then. Mom says pretty good? Yeah, you've been pretty, so it's not like, you know,
That would be me.
yeah, it would be a lot of us. Anyway, how's math going? Going pretty good? All right, why don't you head on over to the board for a quick moment? All right. And Marylou is going to draw a shape up there, all right? I want you to draw a three-sided shape, Marylou.
Okay.
And Nandana, what is that?
A triangle.
Tell Marylou everything that you know about triangles right now.
A triangle is a three-sided shape. It has 3 angles.
And what are angles? Can you kind of point out what the angles are?
The angles are right, there's one right there, there, and there.
Do you know what the definition of an angle is? It's two what? That come together.
2 lines.
Yeah, 2 lines that come together. What else?
There's 3 different types of angles.
Can you draw another triangle for me? Do you know what that type of triangle is called?
Mm-hmm.
What is that?
A right triangle.
Why is that a right triangle?
Because it has a right angle.
Very good. And what is the measurement? Do you know the measurement of this right angle?
Yes.
What is that?
90 degrees.
Okay. What would you call this triangle?
An equilateral triangle.
And why is that?
Because all the sides are equal.
Okay, so we have an equilateral triangle, we have a right triangle. Can you give me another example of another triangle? And what would you call that one?
A scalene triangle.
Why?
Because one of the sides is different and 2 of them are the same.
Okay. Is that scalene or is that isosceles? I think what you're thinking is isosceles. An isosceles triangle has 2 sides that are congruent.
Oh.
The scalene has all 3 sides are different. And this type of triangle is called an obtuse triangle. Why? Why is that obtuse?
Because one of its angles is an obtuse angle.
Can you kind of make an arc on that obtuse angle for me? And what is the definition of obtuse?
It's going to be greater than 90 degrees.
But less than? What does that equal? Do you know what a straight line equals? What?
180 degrees.
So obviously it has to be less than 180, right? Okay, so we have this. If this is an obtuse, what are both of these?
That's an isosceles triangle, and that's...
The right, but their angles, do we have obtuse angles? Or what's the name of an angle that's less than 90 degrees?
Acute angles.
So this might be an equilateral, equiangular, because it's all, and it's acute, isn't it? Because everything's cute. And then this one is acute as well, because all the angles are less than
90 degrees.
Yeah, 90 degrees. Okay, so let's talk about perimeter. Do you know what I mean by perimeter? Mm-hmm. Okay, perimeter, what do I mean by perimeter?
And we'll give you guys 1 moment to experiment with perimeter a little bit and delve into that, and then we'll
come back.
Go back to it.
What's the definition of perimeter?
So, how you find like a perimeter is like you take a shape and you find all of the lengths of its sides.
Okay, so find me the perimeter of our equiangular triangle.
9 inches.
Well, how did you get 9 inches?
Because we have to add all the sides.
Very good. So we have 3 plus 3 plus 3, which is?
9.
Very good.
All right, so you girls will continue with that a little bit later on. Do remember we have phone tutors available until 5:30 this afternoon. Right now we're going to go out and about to the Bakersfield Tower and visit with Scott.
Hey, thanks, Mike, and happy Halloween to everybody back in the studio. We're here live at the Air Traffic Control Facility here in Bakersfield, and we get a chance to talk with Annie Long. Thanks for being with us. Appreciate it.
Hello.
Can you tell us what you do here? What's going on here?
Yeah, of course. Hi, my name is Annie Long. I'm an air traffic controller here at Bakersfield.
Okay.
And today I'm going to talk a little bit about my job and what we do on a day-to-day basis. So an air traffic controller is responsible for getting your airplane from point A to point B safely and efficiently, with safety being absolutely the #1 priority.
Right.
And it all starts here right at the tower.
Okay.
So once you board your aircraft and the pilot shuts the door, they call us up, and we have 2 different positions in the tower. We have ground control and local control.
Okay.
And ground control is responsible for giving your pilot instructions to get from the terminal out to the runway
Okay,
safely.
that makes sense. On the
And-
ground, yeah.
And after that, we hand it off to local control, and they are responsible for the runways, and we clear them for takeoff. And once they are airborne, we hand them off to the next facility, which would be our radar room.
Okay.
And so, as you can tell, it's a lot of teamwork, cooperation, open communication, not just
Right.
among ourselves in the tower cab, but with the pilots and other traffic facilities and the people we hand it off to. And
there's communication going on the whole entire time, right?
Absolutely,
Now, all of
absolutely.
that is happening in this building, is that right? Okay.
and
And it goes from one place to the other. We got to be able to communicate effectively and efficiently, right? So how do they know when to go from place to place? Is it just location? Is it geographic place, wherever that plane happens to be?
yes, we have certain cutoff points. So once they hit the certain point, we hand it off to the next controller.
Okay.
And we have specific phraseology we use over the radio to make sure it's clear and concise, and there's no terms, and like we know for sure what we need to say when we need to say it.
Right, right. So what kind of training do you do for this? Can you do all those jobs in that building?
Not yet.
Okay, but
I'm
you're gonna get there.
I'm on my way. So
All right.
we have 4 different positions here specifically in Bakersfield.
Okay.
So we have 2 up in the tower and 2 down in the radar room. And the time it takes from when you step in the door to when you're completely finished is about 2 years.
Wow, all right. And that's not including the school part, right? So you have to go to school for a while, and then you get here and do some on-the-job training for 2 years?
Yes, I got my bachelor's degree,
Wow.
which took 4 years, and then you go to Oklahoma City for about 3 months. And
Okay.
after you pass that successfully, they send you out to a specific facility for the on-the-job training part.
Gotcha. So you can do some specific jobs wherever you are and learn on the job and learn from the people who are doing that job at the moment.
Absolutely, it's all on the job. You experience as a best teacher.
Right, right. Now I'm sure you did a little bit of math. Maybe just a little bit of math on the path.
Definitely,
What's the
definitely.
main math that you use on a day-to-day basis? Obviously the computers are doing lots of math for you.
Yeah.
But what kind of math do you have to do as an air traffic controller?
Time, speed, and distance.
Okay.
Yeah, so on our scope, we can see how fast the aircraft's going, how far they are from the airport, and then it's just a lot of mental math to determine where to sequence these aircraft and where to
Right.
place
So you got to
them
be
where.
doing some stuff in your head, and you have to be able to do it kind of quickly. And of course, you're going to have some instruments to back you up to make sure those numbers are correct,
Definitely,
right?
definitely.
Gotcha. So we got a chance to look a little bit and see what you do on your job, right? We got a chance to be inside. Can you tell us what we're looking at here? What were you doing at this time? What were you doing when we got a chance to see the radar room and see what you were doing in the tower? What are some of your responsibilities when you're doing your job?
So we control the aircraft completely off of our voice and
Okay.
through our speech. So as you can tell, we're always constantly scanning for traffic and anything around them, and our job is to update the pilot of everything that's going on around them at the time and anything
Right.
they might see, throughout their route of flight. And
Because you're not just responsible for that one aircraft. You're responsible for all the aircraft that are around this area, right?
oh no, yeah, definitely, we're talking to dozens of aircraft
Right.
at once, and it's just a lot, like I said, a lot of coordination with us and the neighboring controllers and
Yeah.
everyone in your own
Yeah.
facility.
So when you're at the very top in the tower and you can see out on at the airport, right? You're looking for aircraft that you can see, but then the communication goes to the radar room, right? And how far out does the communication go there?
About 40 to 60 miles.
Okay.
Yeah, and then after that, they get handed off to center, which they get to see like hundreds and hundreds of miles worth of airspace.
Oh, gotcha. Okay, so when the aircraft gets up to cruising altitude, when they're just cruising along from point A to point B, they're going to be talking much less frequently, probably, right?
Yes.
But they're going to be talking to someone who's not a local here. They're a little bit bigger facility. They're talking to aircraft from all over the place.
Yep.
Gotcha. And then what happens when they get close to where they're going to be?
The process starts in reverse. So
Ah.
the center gets handed off to the radar room, and then back to the tower, and then they land safely, and then go back to parking.
Wow, so all kinds of communication and math going on the whole time. Well, we want to know a little bit more about what goes on in this building. We want to know a little bit more about what goes on in this facility because it's all behind closed doors. And everyone knows about the tower, but maybe not what actually goes on in there. And we want to know more about the people. We know there's some more math to do in the studio, so we're going to go back there first. But when we come back, we're going to learn a whole lot more about what happens out here at Meadows Field. Back to you in the studio, Mike.
All right, thanks for that, Scott. Lot of interesting things that happen in the Bakersfield Tower that people are not fully aware of. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. As you can tell, it is Halloween today by looking at our rainbow troll in the back right there. We also have Nandana, a 5th grade student from Stockdale Elementary, in here doing some great mathematics with us, and we're going to get to her in just a little bit. But right now we're going to go to the phones. Caitlin, how are you this afternoon?
Good.
And I take it you're not working on equations today, right?
No.
All right, as soon as you're ready, let's hear the math problem you are working on.
A speed of 16 miles per hour is equal to 88 feet per second. If the speed limit in a school zone is 15 miles per hour, what is the speed limit in this zone in feet per second?
Okay, so Caitlin, do I have this right? We have 60 miles per hour, which is equivalent to 88 feet per second. So the other one is 15 miles per hour, and we need to find out how many feet per second, correct?
Yes.
Okay, so we could set this up as a proportion, and there's a lot of different ways you can write a proportion. We can write it as miles per hour over feet per second, or we can write it as miles per hour over miles per hour, which equals the feet per second over the feet per second. So there's a couple different ways we can go. But the biggest thing you have to remember, Caitlin, is that you have to make sure that your information stays the same. If we're doing miles per hour over miles per hour, if I'm starting with 60 and I'm going to do 60 over 15, then I need to make sure that my numerator for the feet per second is 88 because it matches to the 60, and then my variable is going to be in my denominator because that's what we're trying to find out for the 15. So again, there's a couple different ways you can set it up, but again, it's really important to make sure that your information stays constant, stays the same. So let's go ahead, and I'm going to go ahead and solve it. Whoops, let's get those out of the way. I'm going to go ahead and solve it as miles per hour over miles per hour.
Yeah, let me just delete those triangles quick.
Please, that would
All
be
right.
lovely.
Let me see if I can take care of this for you here real quick.
Okay. So I'm going to set it up as 60 miles per hour over, oh, thank you so much, over 15 miles per hour. It's equivalent to 88 feet per second over x, okay? So here I just simply have a fraction, and the first thing I want to think about is these are big numbers. Can I simplify? Because I really don't want to be working with that. Well, does 15 and 88, do they have a common factor? Not really. So I'm going to have to probably do some cross multiplying. So let's go ahead. What I want to do is I want to cross multiply 15 times 88. So over here, let's quickly multiply 15 times 88, which we have our 40, again 44, and then we have our 8 and our 8. Adding those together, we have a 12, 13, we have 1,320. Then I'm going to also cross multiply 60 multiplied by x. So let's set this up. I have 60x is equivalent to 13,020, or 1,320. So now I have a one-step equation, and obviously I need to get x by itself because that's what we're trying to solve for. So I'm going to divide both sides by 60. And what I really want to do, I need some room here real quick. we want to divide 1320 by 60. So we have our dividend and we have our divisor. And I know that 60 goes into 132 two times, which is 120. I have 12 left over. And obviously 60 goes into 120 another two times. So what does that tell us? That when it's traveling 60 miles per hour, which is 88 feet per second, when it's traveling 15 miles per hour, it is going to be 22 feet
per second.
Thank you, Caitlin. There you go, okay? And I know there's another quicker way to do this, is there not?
Yes, there is. Caitlin, are you still online with us?
Yes.
Okay, what I want you to do is I just want you to think, we're going to do a little bit of mental math right now, okay? You're going from 60 miles an hour to 15 miles per hour, correct?
Yes.
And if you take 60, what do you have to divide it by to get to 15?
60 divided by 15.
Right, so 60 divided by what will get you to 15?
Oh, 60 divided by 4.
Okay, so divide it by 4 and you get to 15, right? So just divide the other side by 4. So go 88 divided by 4.
Equals 22.
And that's another way that you can get to the answer a little quicker, and that way it can kind of check to make sure that it is a reasonable answer also. Sometimes if you get stuck on a standardized test where you have to do some problems quickly, there are some shortcuts where you can do things like that. Does that make sense to you?
Yes.
All right, well, congratulations, thanks for the call. And because of that, you will also be going to attend a Bakersfield Condors ice hockey game. So congratulations for that. Hey, we do have phone tutors available until 5:30. Nandana was sitting there watching that and trying to figure out how everything was going. So we're going to get you back to work so that now you can show us all the things you know. You ready? All right, back to the board, young lady. I know that you were just doing a discussion on triangles and perimeter of triangles, the different properties and the characteristics of triangles, the different classifications and things like that. So only what we're going to do now is talk about the area of a face.
Give me a number.
7.
7? Okay. Okay, so what shape is this?
Square or cube.
Well, it's a cube, right? But the face of this is what?
Square.
You sure it's a square? It can also be something else.
Rectangle.
A rectangle. What's the difference between a square and a rectangle?
In a square, all the sides are same, and in a rectangle, two of the sides are different.
Okay, so we talked about perimeter last time, right? That's where we would add up all the sides. Well, on this face, which it's a rectangle because the measurements are different, we want to find area. Now, do you know the real definition of what area means? What is that?
To find an area of something, you multiply the length and the width.
But what's the real definition? That's the algorithm, okay? That's how we solve it. But what is the area? What the area is really saying is how many 1 by 1 or 1 foot squares, because my units is squares, is feet, excuse me. So
Can fit inside?
yes. So how many 1 foot squares can fit inside here? And my drawing is not very good right now, but how many little squares can fit inside? Because when we give our answer, we always say squared feet. That's why, because we're saying, hey, how many squares can we fit inside of there? So again, you gave me the algorithm and you're telling me we do what to find those?
Length times width.
Okay, so we have our length times our width. Can you write that out for me and solve that problem for us? Okay, so we know that, and I'm going to get this all off, we know that this rectangle is 56 feet, correct? Okay, so now if I told you that this was 3 feet.
Now, before we keep going, we know that the answer when you multiply 7 by 8 is 56. but it's 56 what?
We're forgetting that, our units of measurement. What did I just say? What did we fit inside? What shape? How many little what?
Rectangles?
Not rectangles, but
Squares.
squares. So it's 50, it should be 56 squared feet.
Square feet?
Right, so we show it with a little
2.
2, right? A little 2, because it's telling us I can fit 56 little 1 by 1 foot boxes inside that, okay? So let's go here. If I know that this is 3 feet, can I figure out the area of this side? What is the missing information?
The width.
Right, and where can I find that at?
Volume?
Well, let's see. This is 8 feet, right? This is
7 feet.
this line parallel to this line? So if this is 7 feet, this also has to be,
7 feet.
is that the missing information we need? Okay, now how do I find the area of that rectangle?
7 feet times 3 feet.
Go ahead, let's figure that out. What? There you go.
Nicely done. So, and you guys have done 2 of those faces right there. And we'll move on to the other shape in just a little bit. But just a reminder, we have phone tutors available until 5:30, and we'll be back with more right after this. Today we're on the Central Coast. We're at Grover Beach Elementary, home of the Golden Gophers, and we're here to All right, once again, we are with some students at Grover Beach Elementary. We've had a lot of bit of fun with the polydrons and making things out of those 3-dimensional shapes. Moving on to another activity right now, we're going to look at a word problem. And there are a lot of different ways to solve word problems. Do you guys have any strategies? Like when you see a word problem, things like strategies like, oh, this is how I can do it?
I put it into numbers.
Okay, so you take the words and put them into numbers, right? Make it a little bit easier. What else can you do?
Reread.
Reread it, because sometimes you miss a word or you maybe misinterpret something that they're asking for. What else?
If you don't understand it totally, then you could circle it or highlight it.
Circle words, highlight.
Written information.
There you go. So you want to look for important information, maybe turn things into other numbers, figure out what operation you're going to have to do, right? What is the outcome that they want out of this thing, right? So you kind of figure that out as you're going through it. So here's a problem that I have for you right now. We have 24 feet of fencing. Right? You guys know if you wanted, like if you had a little garden or something, or at your house, you have fencing that goes around it, right? Okay? So if we have 24 feet of fencing, and I wanted to use that fencing, and I wanted to use all 24 feet, how could I arrange it to use all 24 feet?
There are multiple ways. You could have a cube, and there are 4 sides. Each are 6 feet.
Okay, so I could go like this, right? Where I've got 6 feet here and 6 feet here. And if I come all the way around, will that make 24 feet going around?
Yes.
Yes. Now, is that the only way I could do it? What else could we do?
Another way is that instead of it being 4 sides, if it was connected to the house, it would be 3 sides, and 24 divided by 3 is 8, so it'll be 8 feet.
So I could go like this, where each side is 8 feet, and we have a house here, so you're not using any fencing, but it has a barrier. Is that what you're saying?
Yeah.
So that way we went a little further out, okay? Any other ways we could use 24 feet of fencing to enclose something?
You could have it like an octagon, but 24 sides instead of 8.
So you could go 1 foot each side, right?
Yeah.
That'd be a lot of work, huh? I'm not going to draw 24 1-foot sections though, all right? So think about this. Think about the factors of 24. Do you guys know what factors are?
Mm-hmm.
What are some factors of 24?
1.
1, obviously, right? And 1 goes with what? 1 times what?
24.
24. So let's put 24 out here. All right. What else?
6 and 4.
6 and 4. So let's put 4 here, and we'll put 6 here.
3 and 8.
3 and 8. All right. So let's put 3 right there, and we'll put 8 right here.
2 and 12.
2 and 12. They fit nicely right in there. Any other factors of 24 besides the ones we've got? Because we've got a lot. So we've got 1, 2, 3, 4, 6, 8, 12, and 24. Here's one way you can check. We know that 1 and 24 go together. 2 times 12, 3 times 8, and 4 times 6. Now the 4 and 6 are right next to each other, right? Will 5 go into 24 evenly? No. So we know we're through. Those are all the factors, all right? So you could say, all right, I want a 12 by 2. But is that going to work for 24 feet of fencing? No, because that would give us how many? How much fencing would I need?
28.
28. So you can't just use those factors, but they give you a start on how to do this. Instead of doing 12 by 2, what could I change to do this?
10 by 2.
10 by 2. Right? Now that makes 24 feet of fencing. So we've gone over a little bit of the factors, some dimensions that we could use with 24 feet of fencing. When we come back with the students at Grover Beach Elementary, we'll put forth the task to see who can get the greatest area. And a big thanks once again to Mr. Snyder and all of the students out at Grover Beach Elementary. Hey, you know what? We have Nandana in studio. We've got another phone call to get to, but first we're going to head back out to the Bakersfield Tower and visit with Scott.
Coming up to the double box, stand by.
Hey, thanks, Mike. We're back here live at the Bakersfield Air Traffic Control Facility on this lovely Halloween. Nobody's dressed up here, but they have a lot of really cool things to do. And we want to talk a little bit about how math is involved with all the airplanes that we see in the air. So we're going to talk with Kevin a little bit. Kevin, thanks for your time, man.
Hey, thanks for having me, Scott.
Appreciate it. How long have you been here?
I've been here now for 3 years.
Okay.
3 years. Been doing air traffic control for a total of 8. Started in the military, actually.
I bet you that was a little different experience than what you have here in Bakersfield, right?
Totally different.
Yeah.
Totally
Did that
different.
completely prepare you for everything that you do here in Bakersfield? The military got you ready to take over the tower, right?
Absolutely. It got me prepared, but you know, getting here, it's totally different doing it in the private sector. I won't get into too much on how it differs, but I love the military side, but we do things a little bit more professionally here.
Right. Okay. So, and we got to make sure that everyone's safe and make sure everyone knows what they're doing.
Absolutely.
Now, I'm curious about how you got into air traffic control, because this is my silly story, right? When I was in high school, I took one of those career tests.
Yes.
And it said, when I was a freshman in high school, that I was supposed to be an air traffic controller. So I got really interested in how that went. That it didn't end up being my path, but how did you get involved with this?
Interesting enough, my mother took the same test and said that she was supposed to be one too, but she just never went after it. She had dropped the bug in my ear a little bit, but I was an electrical engineer in college, and after that, I decided it was time to do something different. So I Googled, and air traffic control came to mind from that, from my mother's experience, and I'm glad it did.
Good.
Love this job.
Good. That's good to hear. Okay, so we want to know a little bit about the math that goes
Yes,
on every day.
indeed.
We certainly have a ton of computers that are running all kinds of things.
Sure.
We talked a little bit earlier about the communication that goes on between different towers and different airspace and all that
Right.
fun stuff. But you got to be quick, right?
Absolutely.
You got to be quick. You got to make sure you know what you're talking about
Absolutely.
and not rely just on what you see in front of you, right?
Yes.
So tell us a little bit about maybe some scenarios that might come up on a day-to-day basis, or maybe even an hourly basis.
We are heavily involved with math, and we may not even realize it all the time when we're doing it, but cardinal directions is probably the basis of everything. We start with north, south, east, and west. Everybody knows that. But there are numbers that are actually assigned to those headings and positions. 360 degrees to the north, 90 degrees to the east, 180 degrees to the south, and of course 270 degrees to the west. everything in between there, we can fill those numbers in, but that's the basis for our runways. When you see a runway that's runway 4, that's actually a 004 heading when we're talking about the angles and degrees. So a runway 4 will be a 004. We have runway 30 left and 30 right here, which is a 300 heading, and 120 heading on the other side, which would be runway 12 left and 12 right. Also,
so the numbers, you're using those numbers as opposed to what we might normally say, hey, when you're going down this road, make a left or go to the west, you wouldn't necessarily use those terms. You would use some specific degree measures.
Precisely, and that lets the aircraft know also which way to line up for. If it's if it's 300, they know how they can line up if the runway is 30. We also use geometry with the shaping of our airspace. We don't just control everyone's airspace. It's like a quilt and patchwork when it comes to what we're able to control. Everyone has a piece of the pie. In the tower, which you guys have seen, we have a cylinder-shaped airspace that dissects into 5 miles in circumference, 2,500 feet surface to the air that we control in. You have to have two-way communication to enter our little bubble, if you want to call it that.
Right.
And without that, you can't come in.
So you control that little small area,
Exactly.
right? And you got to know who's there, and you got to
Yes.
know what they're doing, and they have to be in constant communication so that we're as safe as possible. Because again, you're not just talking to that one aircraft; you're talking to everyone in that
Yes,
space.
it can be an infinite number of aircraft. However many we can fit in that cylinder, that's how many we're talking to, and that's in the tower.
Right.
In the radar and the Tracon that you guys have also seen, this entire section, which covers a span of over 120 miles. That's even more aircraft that can fit in there, and that's in transition between Los Angeles, Joshua, Lemoore, and even Oakland Center that we talked to the north there. So it's a very, very large airspace that we're dealing with there.
Right, and because you know all this stuff, your trips on an airplane must be very different than mine, because you know what's going on behind the scenes, right?
I'm listening to every handoff, making sure the controllers are using good phraseology, and make sure that they're using the good math too to keep me separated.
Right,
So
right. So some
absolutely.
quick math that you might do on a daily basis. You're in the tower, and you got a couple planes coming in.
Absolutely.
You drew us a picture here, which I think is a great example. Tell us exactly what happens in the first one here.
Here's the thing. We want to know, do we have a problem? And if so, we know math will solve it. So here we've got a Cessna doing 120 knots per hour, and he's 5 miles away from the runway. Behind him, we've got a big Boeing 747. He's doing 120 knots as well, and he's 10 miles away. Now, the first thing you notice, oh boy, these aircraft they're doing the same speed. However, this one's twice as far away from the airport as the Cessna is. So do we have a problem there? Scott, I'd say no.
Probably not so much.
I think we've got it
exact
covered.
same speed, different distance. Not
Exactly.
a big deal. They're lined up for the Cessna to land first, the 747 next.
Exactly. So we're going to let them run, and we're going to have a good, safe landing there.
Doesn't always work like that.
No, it does not.
Okay, so what could happen? Another hypothetical
Here's
situation.
another situation here where we have a Cessna doing 100 knots. He's 5 miles away from the airfield, and we've got an F-18 doing 200 knots. She's 10 miles away from the airfield. Now, the first thing I notice is that the F-18 is twice as far away, but they're also going twice as fast. So what do we have there? Looks like a tie to me. And that's
we
a big
don't want
problem.
a tie when they finally get to the airport.
Absolutely not. And it's quick math like this that a controller needs to be able to do to even understand that you have an issue. Because when you're looking at it, it's the same situation. They're both the same distance away from the airfield, but here you got different speeds. So it's going to be important to get the aircraft out of the way so that you can have a safe, expeditious landing.
Right, right. Man, I love it. Some solid mental math there, even on Halloween. Well, we're going to come back at least one more time to make sure we can find out a little bit more about what goes on in this building. But whatever it is, you know math is going to be involved. Let's make sure you all get some problems done in the studio there as well. Back to you, Mike.
All right, well, we are getting the problems done here in the studio, Scott. And, you know, it'd be cool to see if we could get him in that plane going 200 knots.
Oh, yeah.
Just to see his face on, oh, what's going on here? We have to land this thing. Anyway, we have Nandana in studio. We're going to get to some more mathematics with this young lady in a moment. But first, we're going to go back to the phones for another young lady that frequently uses the program. Ruby, how are you?
I'm good. How are you?
I'm excellent myself. You do have an equation to work on today, correct?
Correct.
All right, let's hear it.
It's 12 parentheses m plus 1/2 closing parentheses equals 24.
Okay, Ruby, let's make sure I have this correct. It's 12, open parentheses, m plus 1/2, close parentheses equals 24, correct?
Correct.
Okay, so obviously the first thing we want to do is get rid of these parentheses, don't we? So we need to do what property am I thinking?
Distributive property?
Thank you. We need to do distributive property. So let's multiply 12 multiplied by m, which equals
12m.
12m. And now we're going to say 12 multiplied by 1/2. Now we can do some math, or obviously when we're saying 12 multiplied by 1/2, aren't we really taking half of 12? Is that what we're doing? We're taking half of 12, or are we doubling 12? What do you think?
We're taking half of 12.
We're taking half of 12, exactly. So what's half of 12?
6.
6. So we're going to plus 6 equals 24. Okay, Ruby, what would be the next step? Because again, we're working on simplifying this equation. What would we get rid of next?
Will we get rid of the 6?
Okay, how do I get rid of 6?
By taking away 6 from 24 and 6.
Okay, and what property is that? Starts with an I. Let me help you out. Inverse property. So the inverse property is where we're doing the opposite, because remember, this is an equation. It's a balanced scale. So what I do to one side, we have to do to the other. We're zeroing this out. So now what is 24 minus 6?
18.
Okay. And we're just going to bring our 12m straight down. And Ruby, am I done? Have I solved it yet?
No.
No. What do we need to do now?
We would divide 12 and 18 by 6.
Well, 6 is gone. So I need to get rid of, I need the variable by itself. That's our goal, okay? So we need to get rid of 12. So I'm doing the inverse of multiplication, because this is 12 multiplied by a number. Because you really can't mental math this, can you? 12 times what is 18? We really can't mental math that. So we're dividing both sides by 12. This is a division problem, but it's also a fraction. Ruby, can I simplify this fraction? What common factor goes into both 18 and 12?
2.
Well, there's a number higher. Keep going a little bit higher.
6.
6, exactly. I can divide both of these by 6. So if I divide both of these by 6, what do we get? 18 divided by 6 is?
3.
And 12 divided by 6 is?
2.
2.
And if I'm not mistaken, I think on her work problem there, she's going to need to leave that in that form.
That's what my next question was. Because sometimes teachers request the improper fraction. Sometimes teachers want it as a mixed number. But I think you need an improper fraction. So there you go, Ruby. Our final solution is m equals 3/2. But again, I'm sure your teacher always says check your work. So I would suggest to plug 3/2 back in there and make sure that that works. Okay?
Nicely done. Congratulations. And for your effort today, you'll be receiving a free pizza courtesy of our friends at Cubby's Pizza. So congratulations on that. Hey, we do have phone tutors available until 5:30, even though it is Trick or Treat Halloween Day. A lot of kids still have work to do, don't they?
Yes.
You have work to do too, don't you? Yes. Back to the board, young lady. You're not through working. All right. So, Marylou, we've got about 2-3 minutes so we can take a look at that other shape you have and work with that a little bit.
Okay.
Just because we're not going to be able to do surface area and that shape.
Yes. So, what shape is that?
Pyramid.
That's a pyramid, okay? And a pyramid is made up of 5 shapes. Do you know what all 5 shapes are? What's the base?
Square. Rectangle.
Or a square or rectangle. And then the other 4 sides all are?
Triangles.
Are triangles, okay. So we want to find the volume of this, okay? And to find a volume of this, we're going to kind of just put this to the center, okay? Volume is, what did you say the formula for volume is again?
Length times width times height.
Times width, oops, times height, right? Also, this length times width, so you understand on any volume, okay, is always the base, and it's usually labeled as a capital B. It's the base of the object. The base of this object is a rectangle, right? So to find the volume of this, we go 8 times 3. What's 8 times 3?
24.
That's my base, and then I'm going to take that 24 and multiply it by the height, which is?
7 feet.
7, okay? So we do, real quick, do 24 multiplied by 7 for me.
And just to keep you on track, you've got about 3 minutes
Okay.
left.
What'd you get?
168.
So our volume here is, volume equals 168 feet, but it's not squared. Volume is like how many cubes, because squared is how many squares we could fit in. But this is how many small 1 by 1 by 1 cubes can we get in here. So cubed is shown with a what number?
3.
3, very good. Now this is a pyramid. Believe it or not, a pyramid is like, we've taken 1/3 of the size of this. So again, we're going to do our base, okay? Our base here, we're going to say is a 10 by 4. And then the height of this pyramid is 8. So we want to take 1/3, okay? So what is 4 times 10?
40.
Okay, so we have our 4 times 10, which is our base, times 8. So we know that this is 40. Real quick mental math, what's 4 times 8?
32, so
It's going to be what?
320.
320, okay? And we're going to multiply that by 1/3, all right? And to do that, obviously, we can also divide it by 3. Remember, you heard me talking about if I take half of a number, I multiply by half? It's the same with 1/3. I could divide that by 3.
And you girls are in your final moment.
Okay. 3 goes 1 time, 3 goes into 2 0 times, 3 goes into 20 6 times, and we're going to end up with a remainder of, is it 2? Am I right? Nope, nope, nope.
You're right, that'll be
Yes?
the remainder. Because then you'll bring down to 0, you'll have
Yes.
it repeating after that.
Yep. Do you see what I'm doing? There you go. So our volume is 106 feet and remainder 2, or we could change it to a decimal, feet cubed. But always remember, a pyramid we're taking is 1/3 of a cube.
So let me have you do this. Put down 106.66. So just write 106.66.
Right up here for me. Put 106.66.
66, because it would continue on like that. Now,
Right.
if you had to, Nandana, round that to the nearest whole number, what would that be?
Would you round that to 106 or 107?
100.
Think about this. Yes, because that's greater than, it's 5 or greater, right?
Mm-hmm.
That means we need to round it to, go ahead and write your answer down. You could just write it right there. So our volume would be approximately 107 feet cubed.
There you go. So I
All
just
right.
wanted you to round that so we had a whole number there at the end. All right, nicely done. Well, we do have one more opportunity to head out to Meadows Field and visit with Scott.
Hey, thanks, Mike. We're back here live at the Bakersfield Air Traffic Control Facility. And we are in the air. Here we are at the top of the tower. We're here with Josh Birch.
Yes.
Josh, thanks
Hi,
for your
nice to meet you,
time.
Scott. Yeah.
Where are we?
Right
what
now,
are we doing?
Okay. Right now we're out here on the what was called a catwalk, right outside of the tower cab, where our positions for local control and ground control are talking to the aircraft that may be outside the facility or getting ready for a clearance to leave for Meadowsfield. So obviously there's not a whole lot going on right now. Sometimes traffic slows down, there's lulls, and then there's highs at some peak times for these aircraft to come in.
Right. Yeah, so you have up and down times.
Yeah.
And I'm sure that probably mirrors in the staffing that happens here at the tower, right?
Yeah.
So tell us, if you, in your job, what kind of hours do you work? When do you work? How many people are here when you're working?
Okay, we typically run 5 days on, 2 days off, work weeks with 8 hours a day.
Okay.
I think we have 5 shifts that overlap throughout the day. And anytime there's 2 people up in the tower, 2 people down in the TRACON with a supervisor in each spot.
Right.
So, I mean, that's the optimal day. Slower times or early in the morning or late at night, the traffic's lower.
Right, and you have some serious responsibilities. You got to make sure people in the air are safe.
Yeah.
So is it an 8-hour intense shift where you are watching planes the entire time?
Sometimes it can be, like Memorial weekends. Sometimes during the holidays, the traffic gets a lot heavier than we're used to, and we have to open up more positions and maybe even ask for more help from someone that may be off and have overtime in or something. But
Right.
I mean, traffic, it comes. There's no plan to it. It just comes and then it
you
goes.
got to take it when it comes. You can't just tell them all to go home or stay on the ground for a while. We're too busy. You got to take it as it comes, right? Gotcha. Okay, so if someone wants to get involved in being an air traffic controller, what do you suggest? What do they have to study? What is the educational process? What is the training process?
Okay, for air traffic controller, there's a few different ways to get into the air traffic control job. You can go to school. You can there's CTI schools. There's military. You can join the military and get experience in that. We have, I think, 80 to 90% of our workforce here at Bakersfield Tower has prior experience in the military.
Okay, well, that makes sense.
Yeah. So it's like, I know you talked to Annie and Kevin before already, and Annie spoke a little bit about the job aspects and what we have here in the tower. And Kevin is a prior service as well. And so there's some qualifications such as age. You have to be 30 or younger to apply. You have to pass a medical evaluation. Let's see, you have to be a U.S. citizen. You have to pass a background check, and
you got to know a lot of math, right?
Yeah,
you got to know a lot of math.
You have to have a love for math. Really.
Sure.
I mean, math's involved in everything every day, even though we don't see us using it.
Yeah.
It's amazing. So.
Yeah. Oh, we're so glad to have been out here. We're very grateful for your time. Yeah. We want to make sure we leave you with the famous do the math tile. We'll see if we can get that put down right there on the runway somewhere, maybe. Or maybe not. Maybe on the wall inside the tower.
We're working on the runway right now.
There you go. Maybe we'll get the do the math tile on there so you can see it right as you land next time.
Amazing. Thank you so much.
Appreciate your time. We learned a whole bunch about being an air traffic controller and what kind of math is going on out here and the amazing things that these folks do to keep all those aircraft safe. So I hope everybody has a wonderfully happy Halloween. Be safe tonight. Watch out for those planes. Maybe you can wave at them while you're out there trick-or-treating. But at the moment, we'll go back to you, Mike, in the studio.
Thanks for that, Scott, and thanks to everybody out at Meadows Field dealing with the Bakersfield Tower and all of the different components of that and all of the different mathematics that they presented us with today. Just an incredible amount of mathematics that goes on out there on a regular basis. Hey, do remember we have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. We would like to say thank you to Nandana for coming in. And have you ever had a uniform before?
No.
You have a uniform now because you are an ambassador for Do the Math. Are you good with that?
Yes.
Do you have any idea what your duties are now?
No.
Okay, as an ambassador, you have to go out every day, just like you're going to work, and you've got to let everybody know about Do the Math. Can you do that?
Okay.
Every day?
Okay.
Okay, yeah, why not? You know what? That's a good deal. You know what? Every once in a while, if you see somebody having some difficulty with math, you can tell them, hey, call Do the Math. They'll help you out. And maybe you can even help them out. You good with that?
Yes.
All right, sounds good. We'd like to thank Nandana as well as our Rainbow Troll. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, KERN Schools Federal Credit Union, Panama-Buena Vista Union School District, Bakersfield City School District, and the KERN High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.